Alright, problem 3. We have these 3 blocks resting on a horizontal surface, all of the same mass. Center block has a coefficient of kinetic friction, while the other 2 blocks are frictionless. So, apply a force and move it for 2 seconds, or apply the force for 2 seconds, let it go, and we have to answer questions about what's going on. So, first thing we want to know is what's the speed of the center block and how far it traveled after the force F is removed. But really, what we want to know is the acceleration of block 2, or the center block, while this force is active. So, to think about what's going on here, we've got our let's see, there we go. We've got our blocks. There's M, and there's M. Cruising along there, or being pushed. It's applied to this one, and it's, let's see, it's this, oops, that's probably my fiance, so hold on a second. Alright, sorry about that. Had to answer the phone and just ordered some pizza. So, we've got, as I recall, no friction here, and no friction, I'm drawing mu equals 0. No friction here, no friction here, and here we have some coefficient of kinetic friction. So, one of these objects then is going to have friction, and it's going to be the middle one. So, let's say there's going to be normal force there. There's going to be a normal force there, and there's going to be a normal force there. I'm not going to label them N1, N2, and 3 for the moment. You'll see in a minute why. All 3 of these blocks are going to have, let me tell you what, let me just draw something a little bigger. All 3 of these blocks are going to have weight mg. So what I'm going to do is I'm going to say we need to find the friction force for this thing. So, and then it's going to have some kind of, there's going to be some interaction forces there, some normal forces at these interfaces where the blocks touch. But look, let's think about this here. Each of these blocks has a weight mg, which means it's going to be a normal force for each of these blocks. There are no other forces acting vertically in this entire problem, just the weight and the normal force, which means each block's normal force has to balance its weight. And in fact, they all have the same mass, so they're all going to have the same weight. So M is the same for all the blocks. So that means for all the blocks, normal force is just going to equal little m times g. We said little m was the mass of one block. And here the friction force here, so that's this. Friction force then, we know, is going to equal mu times n. And it's just a coefficient of kinetic friction. And so it's going to equal mu k times mg. So, that's pretty easy. So now if we do, we can actually look at now at the whole system. So let's look at, here we go. So we're pushing on block 1. Now there's no friction here. There is friction here, no friction here. If we push on this block, what's going to happen is these are all going to slide. There's going to be friction here pushing backwards, which means this one's going to push back a bit. But meanwhile, you're still pushing this one to accelerate, right? So as long as you're accelerating, you're actually pushing all 3 blocks at once. So you've really got all 3 blocks moving. So you're pushing, you're accelerating an object. Here's what it looks like. You have this object, which has a mass of 3m. Okay? You've got an applied force F from the right. You've got some friction force here, which is equal to, is this friction force, which is just mu k times mg, because it's only the friction, you only get friction from this one block, and it's one normal force. It's 1 kilogram worth of normal force, or 1 m worth of normal force. You have, of course, normal force there, which is going to be 3 times this n we've defined. You've got a weight of 3 mg, and that's it. So what we can do now, we do the free body diagram for all m's. Okay, for all so this is for all three masses as a lump. I'm going to do my x, y here, x, y, and here's our 3n. Here's our applied force F. There's our friction force. And there is our 3mg. Let's sum forces in the x direction. There's actually, see, what's happening vertically doesn't matter anymore. Now that we've gotten the friction force out, we don't care about the rest of that. So sum of forces in the x direction is going to equal mass times acceleration. Remember, this is accelerating like that. That's our acceleration to the right for all three blocks. So sum of forces in the x direction, we have this F minus the friction force equals, and it's actually going to be all three blocks mass, right? So I should have written 3m, but it's the mass of all three blocks. So it's going to be 3m times A. So let's see, friction force we found was equal to mu k times mg. So this is going to tell us F minus mu k mg equals 3ma. And if we divide through by m, in fact we can divide through by 3m, so we can say A equals, I don't know, how do we want to do this? So we can say A equals mu kg over 3, okay? Well, negative mu kg over 3, yeah, it's kind of ugly. So plus F over 3m. Well, let's plug in numbers. So let's see, what do we have? So our force was 20, which means, so this F is 20, m equals 3, right? Oh, sorry, m equals 1. So F is 20 newtons, m equals 1 kilogram, and mu k equals 0.5. So, and we're going to use g equals 10 meters per second squared. So this means acceleration is negative 0.5 times 10 over 3 plus 20 over 3. This is a negative 5 here, and this is a positive 20, so this is going to be 15 over 3. So acceleration equals 5 meters per second squared, which means, scrolling on down, then what are the distance and speed, you know, after the 2 seconds? So, yep, let's see, sorry about that. So delta t equals 2 seconds. So v final equals v initial plus a delta t, right? Acceleration was 5, so this is, and v initial was 0. So v final is 0 plus 5 meters per second squared times 2s, which means final velocity is 10 meters per second. And then delta x equals, let's see, what is it going to be? V naught times delta t plus 1/2 a delta t squared. So v naught was 0, of course. Delta t was 0. Well, no, sorry, delta t was not 0, but 0 times the 2 seconds is still, 0, obviously, plus 1/2 times 10 meters per second squared times 2 seconds squared. So this 2 cancels this 2, and then it's just, is that right? Oh, no, it wasn't 10. I'm sorry, it was 5 meters per second squared. That's right. Okay, so 5 times 2 is 20, divided by 2 is 10, whatever you want to do. So delta x equals 10, and meters per second squared times seconds times seconds gives us 10 meters. So that is our answer to part A. Let me check the clock. So that's been about 10 minutes. So I'm going to do parts B and C in a separate video.